Welcome to the second session of Playing with Numbers. Last class, we have learned about factors and multiples. Children, when we deal with large numbers, the process of actual division may be time consuming. Today, we learned some techniques which help us to check whether a number can divide the other number without actually doing the division. Have you thought about it before? Or rules of divisibility. The rules of divisibility helps us to know if a number is divisible by another without actual division. Let us start with the divisibility. A number is divisible by 2 if the digit at the ones place is 2, 4, 6, 8 or 0. That means however big the number is, we have to check the digit at the ones place alone. Here we have an example. It's 11,736. Though the number is very huge, we have to check only the digit at the ones place. Which digit comes at ones place? As you see, it is the number 6. It is divisible by 2. So we say the whole number, that is 11,736, is divisible by 2. The case of another number, that is 5, and test the divisibility of 5. In the case of 5 also, we check the digit at the ones place. Here, the ones place must be 0 or 5 so that the number is divisible by 5. For example, here we have 8,74,615. The number at the digits place is 5 so that it's divisible by. Think about one more case where the divisibility we see by looking at the digit at the ones place. It's also the number 10. Check for the digit at the ones place. If it is 0, the number is perfectly divisible by 10. Here, as you see, in this number, though it appears to be a huge number, 8, 5, 2, 3, 4, 0, the digit at the ones place is 0. So, obviously, it's divisible by 10. The divisibility of 2, 5 and 10 by having a check at the digit at the ones place. To divide, to check the divisibility of any number by 2, the ones place must be either 2, 4, 6, 8 or 0. Regarding 5, the ones place must be 5 or 0. As we have learned for 10, the digit at the ones place must be 0. I think it's clear. That means for 2, 5 and 10, we have to check the divisibility test by looking at the digit at the ones place. Test by 3. Have a look at the number 1026. You add the digits of that number, that is 1 plus 0 plus 2 plus 6. It gets you 9, and it's a multiple of 3. Now, why we did like that? Let's check the divisibility test of 3. In the divisibility test of 3, it states like this. If the sum of the digits of the number is a multiple of 3, then it is divisible by. Similarly, the divisibility test of 9. Okay, it states that the sum of the digits of the number is a multiple of 9, then it is divisible by 9. It's same as how we do the divisibility test of 3. So 8 plus 1 plus 2 plus 7, that's equal to 18. Indeed, it is a multiple of 9. So we say that 8127 is divisible by. In this case also, we can come to a conclusion by finding the sum of the digits. That is, for the number 3, the sum of the digits must be a multiple of 3, whereas in the case of 9, the sum of the digits must be a multiple of. Let us take the divisibility test of 6. As you know, 6 is the product of 3 and 2. If the given number, it happens to be divisible by both 2 and 3, then the number is divisible by 6. Here, the example given is 3006. The digit at the ones place is 6, which is an even number. So obviously, it's divisible by 2. When you sum the digit 3 plus 0 plus 0 plus 6, the answer is 9. That means 9 is coming in the table of 3. So it's also divisible by 3. So the given number is divisible by both 2 and 3. So that 3006, we say it is divisible by. Let us check for some more divisibility test. The divisibility test of 4. The given number, we have to see the last 2 digits, that is ones and tens. If those 2 digits alone is a multiple of 4, then the number is divisible by 4. For example, you can have a look at this number 298716. Though it appears to be a very big number, the last 2 digits, that is 16, it's a multiple of it's a multiple of 4. Sorry. So it is divisible by 4. The whole number is divisible. Similarly, we see the divisibility test of 8. Take the last 3 digits, that is ones, tens and hundreds. You divide that with 8. If the remainder is 0, the number is divisible by 8. Have a look at this number. For example, 75,480. Take the last 3 digit, that is 480. Divide it by 8. It's exactly divisible. We get the quotient as 60 and the remainder as 0. So we see that the given number, that is 75,480, is divisible by 8. Let us check. 480 is divisible by 8. 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 480 is Now, let us see the divisibility test of 11. It's quite interesting, the divisibility test of 11. We follow 3 steps to get the answer. In the first step, we find the sum of the digit at the odd places. And in the second step, we find the sum of the digit at the even places. Step 2, you find the difference of the sum so obtained. Step 3, you check whether the answer you got is 0 or a multiple of 11. If so, it is divisible by 11. Let's have a check with an example. The number given is 1111. Find the sum of the digits at the even places from the right. It's 1 plus 1, which gets you 2. Get the sum of the digit at the odd places. That also gives you the same answer, 2. Difference of those two answers, which gives you 0. So the given number, it is divisible by 11. Isn't it quite interesting, children? So today we have learned the test of divisibility of the numbers. As to save our time in working out long divisions. Hope that you are clear with the rules. Go through the videos again. If at all you have got any doubt, you may clear with me. Hope to meet you soon in the next video. Thank you. Have a nice day.